Hey everybody, I'm Laz. Welcome to projectmanagerhelper.com. For this video, I'm going to show you how to do graduate level regression and statistical analysis using the tools in projectmanagerhelper.com here. So I'm going to first show you how to transform data into regression-ready data using this program. Next, I'm going to show you how to detect distribution and correlations of variables within your data. Next, we're going to assign a dependent variable and a variety of independent variables and explore different regression models and classification models. Next, we're going to do some variable optimization. So for example, for this video, we're going to download a student performance dataset. So what I want to do using our variable optimization is I want to find what set of variables will be the most predictive of the student having the highest possible grade. That's something we can do here. Next, I'm going to show you how to do Monte Carlo simulations to simulate the output of the dependent variable using our regression models, since these are linked together. Next, if we have time, we'll do some forecasting lab using some of the data, as well as potentially hypotheses testing using the student data set. So the first thing we want to do is download the data set. We're starting from scratch. All right, it is downloaded. Next, we're going to extract all. And here it is. Here's the raw data. So let's go ahead and open it with Excel, so it's a little bit easier to see. As you can see here, this data is not regression ready. It needs a lot of transformation to make it into something we could do statistical analysis and regression on. For example, for school, it has letters for the names of the schools. I believe there are two different schools here, GP and MS. It has more binary data such as sex or gender, female or male. Age, we can use already. Address, there's different parameters for that. The size of the family, greater than 3, less than 3, for example. Mother's education level, starting from 1 through 4, 4 being the most educated or graduate degree. Same with father. Now, whether the mother works at home or it works in healthcare or services or other, same for father, and so on and so forth. A lot of variables that we cannot use yet. Finally, I want to assign as our dependent variable G3, which is the final grade for the term for the students. G1 and G2, those are kind of like the half-term grades, so these are going to contribute to G3. I predict those will be strongly correlated, but we have ways to determine that. So now if we go back to projectmanagerhelper.com, find the Excel transformer application. We'll download that. We can drag and drop or select and import our Excel sheet. And now if we had a very large sample data set with gigabytes of data and millions of observations, we may want to do some random sampling. So we can select, if we only want 1,000, we type in 1,000 here, and the program will automatically parse through the data and select 1,000 random samples. Also, you can do that to test your regression model against holdout data, so you can see how effective your model is for validation purposes. I won't get into that too much here for this example. So all we're going to do is click the button, transformed, and then you click on the transform full and download it. Now we will open that. Voila, this should be a fully regression ready data set. So school turned from names to zeros and ones for the two schools. Female turned into a 0, male turned to a 1. Age, since we already have a number, it stays like that. Address, again, it changes into categories. So if we have binary data such as sex and school, it becomes 0, 1. But for data that has more categories, for example, whether the mother works at home or healthcare, it turns into what is called one hot. So essentially it splits it into as many categories and it assigns ones and zeros. That is a trick that we can use in statistics to be able to utilize that categorical data in our regression models. And then finally, the grades, they stay numerical. So it looks like everything worked out pretty well. All we have to do is copy the Excel table, go back to projectmanagerhelper.com. Now we're going to jump into our second tool here, distribution and correlation. What this is going to allow us to do, we paste the data, import it, and analyze it. Should be very quick. Now, this is going to show us the distribution best fit for each one of our variables. For example, for this variable here, which is the address, it shows a normal distribution with a mean of 0.70 and a standard deviation of 0.46. We can use that for Monte Carlo analysis later on, or many different things with statistics. Here we have a sigma with a p-naught of 0.01 and a shape and a scale. All of that we can input into our Monte Carlo tool if we wanted to use that. And I'll show you how to do that later on. Now scrolling down through these many variables, this looks very nice. Here we have a correlation matrix. So as you can see, school and school, those are correlated one. So it's 100% correlation to the same thing. But you can use this this table here to find out what variables are correlated with each other. So as you can see here, 0.26, G1, which means the grades of the first term, that's just what this means. And you can find in the source document what each one of these codes mean. I already know because I've worked with it before, but 0.26 is correlated with mother's education. So it looks like the more educated the mother is, the higher the grade in the first semester of the student for that year. That kind of makes a little bit of sense. So this is a kind of like a top level check that you can see to see what variables matter for other variables. Negative 0.38, so there's a strong correlation. Again, the grade in the first and second terms are negatively correlated with failures. That makes sense. The more the student fails, the worse the grade will be. So yeah, this is a very easy way to find out which variables are correlated. So enough of that. Now we're going to get into the fun part. We're going to start our regression. So go back to projectmanagerhelper.com, select the Multivariable Regression Tool, and open that up. All you have to do is paste the data you already had copied from Excel, import it. It's going to add it here into our table. We can remove variables that we don't want, or we can add additional variables as well. Now the next step is selecting the dependent variable, which variable you want to try to predict, what variable you want to use regression to predict. In this case, G3, which is the final grade for the year of the student. But you can select if you want predict health, or you can even try to predict the gender, the sex of the student. Now, keep in mind, if you want to predict something that's categorical, like a 0 or 1, you will need to use a classification model as opposed to a regression model. So just keep that in mind. But let's go and select again the grade G3, final grade for the year. Now, the beautiful thing about this web app is that you can just leave the model in the best fit and run it. And this tool will try to identify what the best regression model or classification model is for this data and select it for you. There you go, it finished, and it's recommending you use random forest regression, which has the lowest RMSE, or the root mean square error of 1.3, which is really, really good. And that is without filtering any of the data yet. Here are all the variables. We can use this for variable optimization and predictions. And this is what our regression model looks like, really good for random forest. Now you can generate a report, and it shows you how many observations were used, what the R-square was. This is incredibly good, which makes sense. Probably because we have some strongly correlated variables, as we saw before. The G1, which is the grade for the first half of the semester of the term, and G2, which is the second half, are very indicative of the final grade. So to get some meaningful results, you might want to do some data analytics there and probably remove those so you don't overfit your data. Here are all the variables that were kept. The filter was off. If you turn the filter on, it will get rid of variables that don't have any meaningful correlation, and it will show you which ones it dropped. So for this initial go, we didn't drop any variables. We used all of them. And then what kind of evaluation you want to do. This tool gives you the option to do holdout, which means you're keeping a certain percentage of the data to make your regression model. And then it would also scan your holdout. So whatever you didn't use to train your data, it will run it using the result of the training data, the results of that regression, and it would actually show you if it was a very good fit, if it worked essentially. You can see here visualization, really good fit. Okay, so let's close that out. Here are the error metrics, so you can kind of follow along and see how good your model is. Now, what I would like to do here is make our first prediction. So let's say that student went to school 1, which I forgot what school that was, don't really matter too much. Let's say that the student is a female of age 18 and address 1. You have to again find out what those things mean. Let's do 1 for P status. Family size, let's select 1. I think that means it's greater than 3 family members. Mother's education, let's select 4, which is the highest. Father's education, let's select 4, which is also the highest. Does the mother work at home? Select 1 for yes. Does the mother work in healthcare? 0 for no. Other, no. Now keep in mind, these are mutually exclusive. You can only have one of those at a time. You can do the same thing to all of the variables. There's a lot, I won't do it for all. And then you can predict. And based on all of the variables here, our prediction is that the student will have a grade of 12.7 at the end of the year, and that is out of 20. Now, with an R-square of 93.9%, so really, really accurate results here, or the variation in the predictive variable is 93% caused by the independent variables, essentially what that means. Now, a nice trick here, we can optimize and auto constrain to the min and max, which means if you press this button, it will try to optimize for the highest possible grade that we can get, and it will auto adjust the variables. So let's hit that button. Now it tells you what variables you need to predict the highest grade for the student. In this case, the highest one that was predicted was 17.4, but since it uses random forest methods, it won't be the highest, it won't be 20. But if you use a linear regression model, it should give you the highest possible, which is 20. However, the R-square will suffer a little bit. You can keep predicting and it can get better, it could get worse, but essentially these are the variables that are auto inputted here now. And you hit predict, 17.4. Now let's try selecting our own model. So let's do a ridge regression. It's like linear regression, but it kind of dims the outliers a little bit to kind of prevent some overfitting of the data. Now for reference, I like to select the lowest RMSE. In this case, it doesn't matter because it is not weighing them each against each other. Cool. Now, do we want to filter any variables that are not necessarily good predictors of the dependent variable? You can also, you don't have to. Let's try filtering out. And then how do you want to evaluate? You can do either in sample, if you only run the ones that you want to run, and then you want to test a different set of variables afterwards, or you can do a holdout method, which means you want to set 10% or 20, whatever it might be, as your test, and the rest will be part of your, so we selected holdout. The rest will be part of your training data for the rich regression model. Let's go ahead and run the model. You can see that many of these variables like family size, P status were filtered out. Only the variables that matter, that are predictive of the grade, were kept. And again, we're trying to predict the G3, which is the final grade. Whether the father works at home, it doesn't really matter. However, it does matter if the father's job is a teacher. Makes sense. Whether the student goes to the school because of reputation, that also seems to be indicative. Travel time, how many failures, of course, that will matter. Study time, makes sense. Whether the student has internet or not. How much free time, walking, all of that. And then obviously, good grades for the first and second half of the term matter a lot, I would imagine. So going down here, you can see the coefficient. So the bigger this number is, it means the more of a correlation impact it has. So if the mother works in healthcare, that is very predictive of a higher grade. However, not as predictive as the grade in your second half of the semester or the term of 0.7. That is a very strong predictor. So for real statistical significance, you might want to get rid of this G2 because it is predicting a big chunk of the G3 or final grade. That's what our model looks like. You can hover over these to see what the actual versus the predicted numbers were. But essentially, if I had all of these variables for a student except the final grade, I am very confident that I can predict the final grade of the student within a plus or minus what the RMSE is telling you. If you generate a report, it will show you which variables were dropped, and it will show you how many were kept, and then it will give you the actual coefficient. And then here's the equation. This is the actual linear regression equation, and you can import that to Monte Carlo to actually run Monte Carlo analysis. That's what we're going to do next. You don't have to go to the Monte Carlo app. Just click Run Monte Carlo, and it will automatically load the equation here. So you can predict the G3 or the final grade using custom expression. If you want to just add cost data or duration of activities or averages, you can use any of these preset expressions here, but let's leave the custom one that was automatically imported from the regression model. It also auto loads the different variables with the distribution auto set and the parameters auto listed here. And then 10,000 simulations, run the simulation, and this is what our Monte Carlo analysis looks like for this data set for the end of the term. Looks like the average grade was 11.89 with a standard deviation of 2.89. And then the P10 to P90, meaning the 80% of the results fall between 8.17 and 15.59. You can also adjust the percentile. So if you want to find the 95th percentile, 5% of the students will score over 16.5. That is based on Monte Carlo analysis. And then here is the significant, this is a tornado chart, and it shows you which ones of these variables matter the most for getting the final grade. And then you can generate a report. It shows the equation, it shows what parameters were used, and then it shows the graphs here. You can print this out. This is very useful for projects and all sorts of statistics, but I'll let your imagination run wild on how you can use this. My favorite one though is optimizing. So if I want my kid to have the lowest possible grade in the class, what would I do? Okay, optimize. I have to make sure that the school is number one, whichever one of the two it was. I have to make sure my kid is male, of age 15, whatever address 0 means. I have to look at the legend, which if you go back to the transformed Excel data, there's a legend tab here that shows you what each one of these mean, as far as like which ones were transformed into one hot, yes or no. Female is 0, male is a 1, school 1 is school MS, etc. But you have to go to the original data set to figure out what the actual variables mean. This will explain it all in the documentation. But you can use these tools to produce all sorts of papers or schoolwork or even work reports. Cool. So again, if I want my kid to have the lowest possible grade, which is a -2, I guess that's very close to 0. Or in this case, prediction of a 1 out of 20, so kid failed. Makes sense that half term will be 0 and 0. Now, another thing that you could do a little bit more advanced here is if you uncheck the auto constraint, you can select your limits. So let's say that you wanted, let's say that you're predicting something for your own kid. And let's say that mother's education is between a 1 and a 2, but you're not sure what it is. Father's education, let's say it's a 5. I think it only goes up to 4, but mathematically it doesn't matter here for this. And then let's say that you want to select, so you select the boundaries for all these variables. And then after that, you want to add additional conditions. So you already know that one hot, for example, the mother cannot work at home and healthcare and services at the same time. So you want to find those variables. In this case, you want to go to mjob underscore teacher. You have to make sure that it is named the exact same way, otherwise it'll give you issues. And it'll warn you. See, now it's not as angry as before because we named it exactly the same. I recommend just copying and pasting. So I'm just gonna copy mjob mother job health, comma, paste, comma, mother job is a teacher, comma. Now you have selected one hot, which means only one of these can be true. Next, when you go to optimize, it gives you a check mark, which means it worked, and then it'll make sure that here, when you're optimizing for the biggest loser kid, or let's do the highest, let's be a little bit nicer, it will make sure that it doesn't mistakenly set the mother working in health as well as at home, as well as whatever other variables you're using. It constrains how many of them could be true at once. Also for male and female, you could do one hot, or you could do sum equal to, and you can just put that variable, and then it could only, or two variables, and they can only add up to 1, for example, if you have a binary result. Also, there's other examples where I saw a data set about concrete, different mixtures of concrete. And let's say you wanted to use about 15 kilos to 20 kilos of cement. You can set those boundaries here. And you can say, if you use cement, then you cannot use this other type of thing. That's where this will come in handy. It's a little confusing, but the more you play with it, the more sense it's going to make. And then you just want to keep optimizing variables. All right, so we've done Monte Carlo. Let's go back to projectmanagerhelper.com. We went over distribution and correlation, went over the different regression models, Monte Carlo simulation. I have another video on forecasting lab, so I will not re-attack that one again. And then for hypothesis testing, I also have another video. So please follow my page and go to projectmanagerhelper.com to find those videos on how to do those. But these are all linked together, so you can just paste your data from Excel to find all of those forecasting and hypothesis testing and all those videos. You can also go to templates, and there's a hypothesis templates and forecasting templates from Excel you can download. And then if you go to tutorials, you can go and watch the videos there on how to use each one of these tools. Thank you so much for watching. Again, my name was Laz from projectmanagerhelper.com. Please comment, like, and subscribe for more